Hi, and welcome to today's lesson. Today we're going to go over adding and subtracting polynomials, examples 1 through 4. So let's go ahead and review some terminology regarding polynomials. What exactly is a polynomial? Well, all it is a sum of monomials. Okay, so all it is a sum of monomials. And it looks something like this. Just making up a random polynomial, but it's made up of monomials, okay? That's all it is. This is a monomial, negative x is a monomial, and a constant like 5 can also be a monomial, okay? So what is a monomial? Well, it's these things, okay? Like 3x squared minus x plus 5. It's basically a combination of coefficients and variables, okay? Coefficients and variables. Now, the other terminology that you might run into is something called a binomial, and that is basically a polynomial with just two terms. Okay, bi means two. Polynomial with two terms. If you have a polynomial with three terms, then what you have is a trinomial. Okay, so a binomial is something like that. Trinomial is what we did before, so something like 2x squared minus x plus 3. Okay, there's three terms: one, two, three. You also need to know about like terms. Okay, like terms. And these are monomials with the same variable. That's very important. And same exponents. Okay, variable and exponents, not just variables, but variables with the same exponents. And why do we care? So, like terms. Let me give you an example. Something like 3x squared y and 2x squared y. These are like terms, okay? And the reason is they share the same variables, x and y, and the same exponents, 2 here, a 1 there, and a 1 there, okay? If you have something like xy and x to the third and y, these are not like terms, okay? You have an exponent of 1 there, a 1 on top of the y, and then a 3 on the other one, and then 1 on the other one. So these cannot be, they're not like terms in any way. And you might be wondering why we actually care for like terms. Well, the reason why we care for like terms is because we can combine them. It lets us simplify polynomials. So let's go ahead and try an example. Here we have 7x squared y plus 3a squared b squared plus 3x squared y. Okay, so as I just mentioned before, we can only combine like terms. Well, let's identify the like terms. The like terms are going to be this one and that one. Okay, both of them have x squared y as their variables. And in that case, we can combine them. In other words, we can add it, right? You have a positive 7 and a positive 3. So you can simply add and get 10x squared y, and then you're left with 3a squared b squared as your other term. Okay. This one doesn't have, they're not like, this one is not like terms compared to the other ones. Okay. It's got a squared and b squared. So that's going to be your answer. Let's try example 2. And this is asking us, are the following like terms? And well, here we have xy, here we have x squared y. So No, they are not like terms. Let's try example 3. This tells us to just simply combine like terms. So let's get some more practice doing that. So here we have 9x to the third. Let's see if we have something similar. Well, right here. So we have negative 9x to the third power and positive 9x to the third power. Since they have opposite signs, they cancel each other out. Okay, they're gone. You get 0 as a result. And it looks like these are also like terms, right? So x squared and x squared. This one has a 3 in front of it, and this one has an invisible 1 in front of it. Okay, for those of you who don't know or have forgotten, anytime you have a variable such as x, it has a 1 in front of it. Okay, this is the same thing as 1 times x gives you x. So you can consider, so if you get a variable like x or a or y, they all are going to have an invisible 1 as their coefficient and an exponent of 1 as well. Okay, because something raised to the power of 1 is just itself. Okay, so we can combine these two. So 3x squared plus x squared is going to give us 4x squared. We're done with that. And then we're just left with the negative 7. So we can bring that down. And now our polynomial has been simplified. All right, let's try one last example for this video. It says, write the sum of the rectangles as a polynomial in its simplest form. So whenever you get a question like simplest form, it just means to simplify the polynomial using like terms. Okay, it just means to combine like terms if there are like terms. But to actually solve the problem, how should we go about it? Go ahead and pause the video and try to figure out on your own if you can. All right, so it wants us to find the sum of the rectangles as a polynomial. Okay. And notice how there's 4 rectangles. There's A, B, C, and D. And it wants us to find the sum. Well, if that's the case, then we can simply solve this thing by getting the sum of each rectangle. And what we're getting is the areas for each rectangle, and we're summing them up. So what is the area of a rectangle? As a reminder, the area of a rectangle can be found by multiplying the length and the width of the rectangle itself. Okay, so for the first rectangle A, all we have to do is multiply 2x and 4x, right? So for A, we have 2x and 4x. Okay, so that's the area of A. And then know that, recall that we're finding the sum of each rectangle. So I'm going to write a plus. For rectangle B, we have 2 and x. Okay. So 2 times x is just 2x. That's your B. And then for C, we have 6 and 6x. So we're going to multiply 6 and 6x. And then we're going to add the area of D, which is 5 and 4. 5 times 4, which is 20. Okay, that's your rectangle D. So all we have to do then is to simplify. So 2x times 4x is going to give us 8x squared. 2x we can just leave it as itself. 6 times 6x is going to be 36x. And then we have plus 20. And let's see if we can combine like terms. So that's a like term and that's a like term. Okay. Both have variables, both have the variable of x raised to the first power. So then we can combine it in this way. So we have 8x squared. 2x plus 36x is going to give us 38x. And then we have 20 at the end. And there we go. The sum of all the areas of all these rectangles is going to be 8x squared plus 38x plus 20.